This is our next INB on graphing the 8 basic functions. So we're going to look at 8 functions, and you're going to be responsible for knowing how to graph and to state the domain and range and the 3 points for each of these 8 graphs. There'll be a quiz all on itself, and it'll be these exact same 2 pages on your INB. So the first one we're going to go over is y is equal to f of x, which is our linear function. And we're going to look at some key points. So the first thing that we're going to do is we're going to kind of set up a table of value. We're going to say y is equal to x. And we're going to make a small little table over here. And that's going to be our 3 key points. And we're going to use x values of -1, 0, and 1. So these are our input values. And we're going to wait for our output. So if I plug in -1 up here, I get y is equal to -1. If I plug in 0, I get y is equal to 0. And if I plug in a 1, I get y is equal to 1. Now I'm going to graph those 3 points. -1, -1, 0, 0, 1, 1. Linear is a straight line. Goes through those 3 points. And the linear function has a domain or x values. I can plug any x value into this equation. Has no restrictions, so it's from -infinity to infinity. And for the range, these arrows go down forever and up forever without restriction. So its range is going to output any y value. So remember, range is y value. Okay, my next one is x squared, and that is our quadratic. Probably learned those in Algebra 1. And we're going to do the same thing. All right, y is equal to x squared. Make a little table. And they're going to be the same 3 input values. So we're going to use -1, 0, and 1 for our input values where possible. So I'm going to input -1. So if I take -1 and I square it, that outputs 1. If I input 0 and square it, I get back 0. And if I input 1 into x squared, back 1. So I have -1, 1, 0, 0, and 1, 1. And this function looks like a U, not a V. Okay. And it has a domain. Well, remember, domain are values, are input values, which are x values, and I can input any x value and square it, so my domain is not restricted. And my range, however, though, looking at the graph, is restricted. It does not go below this vertex value. This vertex is at the y value 0 and up. So my range is from 0 and up. My graph does not exist below y equals 0, nowhere down here. Okay, my next value is, or my next function is the x cubed, which is the cubic. And we're going to use the same 3 values. -1, 0, and 1. And so if I cube -1, I get back -1. If I cube 0, I get back 0. And if I cube 1, I get back 1. Together, those inputs and outputs make coordinate points, which I can then graph on the xy coordinate plane. And this one's kind of almost looks like it could be a possible, like a linear, like we had up above. So if we investigate like 2 cubed, we all know that that's 8, and -2 cubed is -8. Just kind of gets me a better sketch of this. Definitely is not linear. Okay. And so any number, domain is my input values. I can input any value into x and cube it. So it's unrestricted, all real numbers. And its range, this graph goes down forever and it goes up forever. So it's going to have every y value output possible, not restricted in the y direction. Okay, my next one is the square root function. And we already have talked about that the square root function is restricted, right? You cannot square root a negative number. So when I create my table of values, the first function that I'm not allowed to use a -1 because I can't square root -1. So I'm going to start with my first value that I can square root. Since this is just x underneath the radical, I'm going to start with 0. That's my first number I can square root. Pen stopped working. There it goes. So square root of 0 is 0. I can also, the next perfect square would be 1. Square root of 1 is 1. And the next perfect square would be square root of 4, which is 2. So I'm going to pick ones that are nice and easy to graph. Wouldn't want to do square root of 3 and get some kind of decimal. All right, now I'm going to graph that. 0, 0, 1, 1, 4, 2. And if I wanted to go all the way to 9, the next perfect square root, then I could come up to 3. It's not a requirement. And there is my square root function. Now remember, my square root, my domain is restricted. Remember, my x has to be greater than or equal to 0, but it can include 0. Obviously, we did that here by square rooting 0. And my range is the same way. It's not going to output a negative number because when I square root a number, it will never output any of these negative numbers. So it is also restricted by 0 to 8. Those are the first 4. Now we'll cover the last 4. The next function is the reciprocal function. And let's do the same thing as we did before. So we're going to get a table of values. And we can plug in -1. Notice this one, you cannot plug in 0, right? So x equals to 0, otherwise we would divide by 0. So I'm just going to use -1 and 1. So if x is -1, I have 1 over -1, which is -1. If I have x is 1, I'll put that in the denominator, and I get 1 divided by 1 as 1. This one I'm going to change to 2 key points. And I'm going to graph those -1, -1, and 1, 1. And because x can't equal 0, we get an asymptote at x equals 0. So we need to put that asymptote in here. And I also have a horizontal asymptote at y equals 0. Okay. And an asymptote is a place where a function or a graph will approach but never cross or touch. So this function is going to get closer and closer and closer to the x equals 0 line but never touch. And on this side, it's going to come and approach the y equals 0 line, but not cross. Okay, same thing on this one. So it's kind of just like boundaries around the two asymptotes, which happen to be the two axes. So my domain is everything but x can't equal 0. We talked about that last chapter. One restricted value because only one causes my denominator to equal 0. On range, we just have to look at this graph. So it goes down forever and up forever, but because it can't cross or touch the y equals 0 line, it will not have a solution at y equals 0. So it's going to have the same restriction in the y direction. But the next function is my absolute value. And we get our x, y. This time we get back to going to -1, 0, and 1. Absolute value -1. Well, that's a distance of 1 to 0. Absolute value of 0 is just 0. Absolute value of 1 is 1. So my 3 key points are -1, 1, 0, 0, and 1, 1. Graph those. Same points as the quadratic, except an absolute value is created by two linear arms. One with the equation y equals -x, and one with the linear arm. And they converge at the vertex, which is the origin. My domain on this one is I can absolute value any single number. There's never a restriction. My range, however, just like a quadratic, I'm not going to output negative numbers. So my range is from 0, including 0, to infinity. Okay, and the last two are exponential and logarithmic. I just had a brain. We'll just write log now, but I had a brain freeze on spelling that for some reason. I think I just got off, but I'm okay. Most people just write log anyway, but it's a logarithmic function. The key thing about these two is these two functions are inverses of each other, and we're going to need the exponential to find the key points to the logarithmic function. Okay, but we first need to remember what an inverse is. An inverse is if I know this function exponential has a solution, some x comma y, then the inverse is going to have a solution of y comma x. For example, this one had a solution of 2, 3. And this one over here is going to have a coordinate point of 3, 2. So that's how they are related. Okay, and vice versa. So on the exponential, we're going to first graph it, and we're going to plug in the same three values, 0, 1, and 2 to the negative 1 is 1/2, 2 to the 0 is 1, and 2 raised to the 1 is 2. So my coordinate points are negative 1, half, 0, 1, and 2, 1. And since this logarithmic function is has a base 2, and this exponential has a base 2 also, these are inverses of each other. And so we're going to use this property that they're x and y's. The inputs become outputs and outputs become inputs. They flip-flop around. I'm going to go ahead and get my key points for my log. So my exponential had negative 1, 1/2. So my log has 1/2, 1. My exponential had a key point of 0, 1. So my log has one of 1, 0. And my exponential had 2, 1. So this one has 1, 2. Okay. I'm going to go head back to my exponential, and I'm going to graph my key points. Negative 1, 1/2, 0, 1, and 2, 1. This one also has an asymptote at y equals 0. And it kind of is like a plane taking off. So, oops, if you noticed, my bad. I don't know why I wrote this one backwards. Working too fast. 2, 1. There we go. I was wondering why this one was separated. So this one's 1, 2. And so my graph is going to approach kind of like a airplane on a runway. It's going to approach, never touch, and then it's going to take off. Oh, like the coronavirus, right? Exponential. Okay, then I have the inverse, which is 1/2 negative 1, and 1, 0, and 2, 1. Notice that this one had a asymptote at y equals 0. And notice inverses switches are x and y values, so it kind of makes sense that even the asymptote switches from y equals 0 to x equals 0. And there's our two functions. So you kind of need the exponential to graph the logarithmic function. That's going to be the case once we get to the exponential and log section in our book. We're going to need the exponential so that we can obtain the key points for the log using their inverse properties. Okay, so the next point The next thing I'm going to do is find the domain and range of both of these. So the domain of 2 to the x, I can input any number into the x. A power can be negative, it can be positive, it can be decimal, it doesn't matter. But negative infinity to infinity. However, if we look at our range, our graph never falls under the line y equals 0, and by definition of this function, it is not going to cross or touch this horizontal asymptote. So it doesn't include 0, but it does go up forever. Same thing over here. Notice that if domain is x and range is y, and inverses switch my x and y's, it would make sense that the domain of this inverse, the log, is the range of values, 0 to infinity, and that the range, which is the y values, end up being the x values of the inverse. We can just double check that. The domain we just stated was from 0 to infinity. Well, that works because my graph doesn't pass that x equals 0 line, so it's not in quadrant 2 or quadrant 3. And it can't touch this asymptote at x equals 0. So it'd be 0, but it does go in the right direction forever, so it includes all those x values. My range is from negative infinity, goes down forever, and slightly goes up forever. And so those things work. So study over these. We'll have a quiz on being able to reproduce this coming up shortly.